An important concept in probability is the multiplication principle, and it tells us how to quickly figure out the probability when we have multiple events in a row. So for this short example, we have flipping a coin 2 times, so we have multiple events. We're going to flip it twice, and we're going to find the probability of getting heads the first time and then heads again the second. So you can figure it out by listing all the possibilities for an example like this. A coin twice could be heads heads, heads then tails, tails heads, or tails tails. So there's 4 options. What's the probability of getting heads the first time and heads the second? Well, 1 out of 4, or 25%. Well, the multiplication principle teaches us how to get this just by multiplying the chances of heads, or our first event, multiply that by the chances of the second event, which is heads again. And this will save you a bunch of time when there's more than just 4 options to list out. What if there were 2,000 to list? You would not want to list all 2,000 and then figure out the probability of your particular thing you're looking for. So let's look at it. The chance of heads on the first flip is 50%, and you get the same chance of heads on the second flip, which is 50%. So when you multiply your chances together of each event, you get the same result. 25% chance of getting heads and then heads. So in a nutshell, multiplication principle: find the probability of the first event and multiply it by the probability of the second event, and that'll give you your answer. So one thing we often do with probability is draw a tree diagram, which helps us organize our probability information and figure out our answers. And you have to use the multiplication principle when you're making your tree diagrams. So in this example, we have a weather forecast. There is a 60% chance of rain tomorrow. And then we have some stats about you driving. When it rains, you get in a car wreck 20% of the time. Not very good in the rain. But when it doesn't rain, you get in a car wreck only 1% of the time. That's still not very good at driving, but it'll suffice for this example. So think of a tree diagram kind of like a story. So we have the beginning of our story. Alright, I'll just put a little dot here. That's our beginning of our story. And we're going to play out these events. And the first one's going to be rain. So this branch of our tree represents tomorrow it's raining. What would our other branch represent? It would be it not raining, our other option. So no rain. Well, what's the chances that we go along this path tomorrow? 60%. That's our weather forecast. So there's a 0.6 chance. So that's the branch we're going to take. What's the chances that it's not going to rain? Well, 60% chance of rain means 40% chance of no rain. So the branches should always add up to 1, because you have to go, if you're traveling on your story, you have to go one of the 2 ways. So it has to add up to 100%. Alright, well, after you've traveled that branch, let's look at our next event, which is, are you going to get in a car wreck or not? So if it rained, you have 2 options. Let's change the color there. So we're on a different event number 2 now. So after it rained, you can either get in the wreck, or you can have no wreck. You drove safely. Well, the same thing plays out for if there was no rain. You still have the 2 options of either getting in a wreck or no wreck. And let's fill in the probabilities of all these branches. So every branch should have a probability filled in. So if it rained, what were your chances of getting in a wreck? 20%. You're not too good. Alright, not too good in the rain. Well, what's your chances, though, of not getting in a wreck? Well, if you get in a wreck 20% of the time, that means you have no wreck 80%. Alright, so if it doesn't rain, what's the chances you get in a wreck? Oh, only 1%, so 0.01. So the chances of no wreck then is 99%. Okay, and again, these branches add up to 1, and so does this pair of branches. From each spot, you always have a choice of either going this way or that way, so it has to add up to 100%. Well, when we use a tree diagram, we can figure out the chances of rain and then a wreck. Use the multiplication principle. This happens 60% of the time it's going to rain, and then when it does, there's 20% chance of wreck. So pull up a calculator here. What is 0.6 times 0.2? You get 0.12. So there is a 12% chance that tomorrow this is the path you're going to take. It's going to rain and you're going to get in a wreck. What's the chances we go along this path? Well, 0.6 and then times 0.8. 0.6 times 0.8, 0.48. So there's a 48% chance that this is the path we take. What's the chances that this would be the path? 0.4, 40% of the 40% of the time there'll be no rain, and then 1% of that time you'll still get in a wreck. So 0.4 times 0.01, 0.004. And then what's the chances that tomorrow there's no rain and no wreck? That's what we want. That would be 0.4 times 0.99, 0.396. Alright, and you can always check to make sure you didn't make an arithmetic mistake by making sure these add up to 1. Because 100% of the time you have to go along some path, so all your options should add up to 1. So 0.396 plus 0.004 plus 0.48 plus 0.12 equals 1. So we did it. We figured out correctly the probability of each of these paths. So when you have a tree diagram, you could be asked some questions. After you fill it in, what if you saw this question? So what's the probability? We'll start simple. What's the probability of no rain? Well, you just look at that option. No rain happens 40% of the time. Alright, pretty simple. What is the probability of no wreck if you know there was no rain? So remember, this little symbol, a line, whatever comes after it is what we limit our scope to. The possible outcomes are limited to what comes after it. So what if we know we went down this path? That's what this is telling us. If we know there was no rain, so we know there was no rain, well, what's the chances there's no wreck? Well, from here, the no wreck chances are 99%. So again, similarly, what's the chances of no wreck if there was rain? What's it asking here? It's saying our options are limited to when it rains, so we know we travel along this path. Well, what's the chances of no wreck if we're right here? Well, it's 80%. Alright, what's the probability of no rain and a wreck? So it's asking us for two events happening. So you're going to look at your final column when it's asking you for two things happening. So it's asking what's the chances you went down the no rain path and then the wreck path? Well, 0.004. One more of those. What's the chances of rain and no wreck? So what's the chances you went down the rain path, it started raining tomorrow morning, but then you got in no wreck? And we've already figured that out. It's the 0.6 times the 0.8. There's a 48% chance that it will be raining tomorrow, but we won't get in a wreck. Thank goodness. And a final type of thing we could be asked looking at a tree diagram. It's from 8.6. It's with Bayes' theorem. So it's like these conditional probabilities, but notice how it's flipped around here. Here we had the wreck on this side and the rain over here. But down here we're asking the backwards. What's the probability that it was raining if we know we got in a wreck? So it's kind of backwards to what our tree graph shows us, because let's look at this one. What's the probability of no wreck if we knew there was no rain? Well, we just start at the beginning and say, okay, so we know it's no rain. It tells us no rain. Well, then what's the chances of no wreck? And we can follow along our diagram. But this one's saying, well, what's the chances that it was raining if we knew we got in a wreck? Well, we can't start at the beginning because there's no branch that says we got in a wreck at the beginning. So what we want to do is look at all the branches that lead to a wreck and figure out what part of those came when it was raining. So let's find all the branches that lead to a wreck. So this branch, rain, wreck, found one. Alright. This branch, rain, no wreck. Alright, so this 48% of the time there's no wreck involved. That's not what we're interested in. No rain, wreck. Alright, so we're interested in that. And then no rain, no wreck, we're not interested in that. So we're trying to find the percentage or the probability that it was raining if we know we got in a wreck. So what percentage of the time do we get in a wreck? Well, we have that figured out from our tree graph. We get in a wreck, like when you add those two together, you get the total percentage. So the 12% of the time plus the 0.004. So that's the total percentage of time we get in the wreck. Well, what part of those was it raining? What part of our total amount of wrecks had rain involved? Well, these didn't. There was no rain along this path, so we're not looking to include these here on our top part. But these, there was rain involved in these wrecks. So out of the 0.124, 0.12 of those involved rain. So you would simplify that down to find the probability that it was raining when you got in a wreck. So then use your calculator to simplify 0.12 divided by 0.124, 0.9677. So 96.77% of the time when we get in a wreck, there was rain involved.